Oh boy, it's time we do some cosine manipulation. Don't be afraid, we'll just, do some cosine manipulating. I guess there's two things I could show you. One is the, whatchamacallit, the secret Olympiad weapon that I can show you. But that's not necessary because there's a pattern, right? Cosine x, cosine 2x, and cosine 3x. So, we'll start with the easy way, the easy route first. So we have from 0 to 2 pi. We have cosine of 2x. Then here we have cosine of x and cosine 3x. We can pretty much manipulate that in with cosine 4x and then cosine 2x, right? We have cosine square of 2x, which is just going to be a half, while the other is just 0 by periodicity. And then we have cosine 2x times cosine 4x. Here we could technically do the same thing, right? Cosine, we get cosine 6x plus cosine of 2x. Yeah, and that's also going to equal to 0. So it seems like our answer should just be pi. Let me double check. It's pi over 2. I messed up somewhere. Oh, I'm dumb. It's because I forgot to divide by 2. Do not forget this. This portion will kill you. Okay. If you forget to divide by 2, I'm sorry. Okay. So do not forget to divide by 2. That was my biggest mistake. Again, the cons of rushing too fast or going too fast, you can forget little things like this. Okay? So, answer is pi over 2. Alright? So, that's the easy way route. And obviously I screwed it up because I rushed over it. But what is the secret weapon here? So, there is a secret pattern for it doesn't have to be like 1, 2, and 3. Like literally any 3 numbers, or even 4 or whatever. Okay? So, whenever you have this, cosine 2x, just this in general. It doesn't even have to be definite. This in general. Okay? There's a secret trick. What we do is we put it in partitions. And then you find all possibilities for -2 and then -3, right? You could also do like -1, -2, -2, +3, whatever. But the reason why we don't count these partitions is because it's gonna equal the same thing as these sets. Does that make sense? It's just gonna reflect. It's just gonna reflect. So we just focus on this instead, right? And this is equal to 6. This is equal to what? 5, 4. I'm assuming this is gonna be 2 and this is gonna be a 1 or 0. Sorry. So what we actually have. So this means that this is equal to, let's see, splitting it. So we have 3 cosines. So that's 1 to the power of, 1 over 2 to the power of 3 minus 1. Okay, so it's 3 cosines minus 1. And then it's cosine of 6x plus cosine of 4x plus cosine of 2x and plus cosine of 0, which is 1. Okay? And this is literally your integral. Okay, this is equal to this. Okay, so that's the secret trick. Okay, does it work for sines? I don't know. Probably not. I could be wrong though. But I have not done it with sines, and I have never seen anyone do it with sines. So I'm assuming, I guess it only works for cosines. But I could be wrong. But this is the secret weapon, right? If it could be any number, any coefficients, it's going to work like this. Okay? And then you can see, by these 3 terms we have periodicity. So you're just going to be left with from 0 to 2 pi, 1/4, you get pi over 2. I was going to be like, don't tell your opponents, and you will be a deadly competitor. But I highly, this isn't really common in integration B, so I don't think you ever need to use it. But that's just there just to keep you, just be aware of that trick. Okay? Alright, I hope that helps, and I'll see you guys in the next video.